Hi there and welcome to this video on linear graphs. We're going to be covering quite a lot of aspects to do with linear graphs today, so fasten your seatbelts and let's make a start. First of all, I want to start off with the basics of coordinates. Here we've got two coordinate grids. The first one we would know on the left-hand side as the first quadrant. That's named because both the x and the y values are positive. We then can look at the one on the right-hand side to have all four quadrants. This is where the x and the y axes are extended beyond 0 into the negative values. The x-axis is the one that runs horizontally across the page, and the y-axis is the vertical axis that runs vertically on the page. Every coordinate has a position marker. This is always done in the order x and then y. Think of it as because x comes before y in the alphabet. Whatever number is in the x position tells us where that coordinate lies in respect to the x-axis. And whatever number is in the y position tells us where that point lies in respect to the y-axis. It's easy to begin and think that we always have to start at 0, 0. In the left-hand side, the first quadrant, the 0, 0 would be here. In our four quadrants, it's exactly in the middle of them. You may know the well-known saying, along the corridor and up the stairs, which you probably learned when you were looking at the first quadrant in primary school. This is saying the first number takes us along the corridor and the second number takes us up the stairs. Let's have a see then at reading these points. Point A on the first quadrant, I can see if I'm starting from 0, 0, firstly I must move 3 along the x-axis and then 5 along the y-axis. So point A has the coordinates 3, 5. B has the coordinates 9 and 0, and that's because it moves 9 across the x-axis, but it doesn't move up anything on the y-axis. Have a go at reading these points of C, D, E and F, and then I'll reveal the answers. C is the point -5, 0. D is the point -3, 3. E is the point 0, 2. And F is the point 4, -3. So what are some handy takeaway tips then when thinking about coordinates? Well, just to summarise, we can always think of along the corridor and up the stairs if you're struggling with remembering which way to move first. All coordinates are written in the form x, y. The first number in the x position tells us the horizontal movement along that x-axis. And the second number in the y position tells us the vertical movement along the y-axis. Let's have a go at some quick questions. You'll have 5 seconds for each, but if you need longer, just pause the video and press play when you're ready for the answers. Okay, so starting at the point 0, 0, I want to move 0 along the x-axis. So I'm going to be staying in that position. But I want to go 4 along the y-axis. So I'm going to go up 4, which means the point in the position 0, 4 is C. Where's the point -2, 4? Always starting from your origin, your 0, 0 position, this time move -2 along the x-axis. That gets me to here. And then move 4 along the y-axis. It gets me onto point A. Now let's have a go at calculating the value of y in each of the following using our substitution skills. Well, if I have the equation y equals x plus 7, I want to substitute the value x equals 8 into that position. So 8 plus 7 would be 15. Therefore, y would equal 15. What about now? Y equals x plus 10, but substitute in x equals 7. Well, 7 plus 10 is 17. So when x equals 7, y equals 17. What about y equals x minus 6 when x is 13? So substitute x for 13, which is 13 take away 6, so y equals 7. Let's make it a little bit more complicated then. Let's get some multiplications involved. Y equals 2x when x is 5. Well, that would be 2 times by 5, so y equals 10 there. Y equals 5x when x equals 6. Substitute 6 where the x is, and remember it's multiplication. 5 times 6 is 30. What about where you have to do a bit of both, some multiplications and some additions or subtractions? So y equals 2x plus 1 when x equals 4. Well, that's just saying 2 times whatever the x is plus 1. In this case, our x equals 4. 2 times 4 is 8, and plus 1 equals 9. So y equals 9. Y equals 3x minus 5 when x equals 10. 3 times by 10 is 30, and take away 5 is 25. What about when the value we're substituting in is negative? You're free to use your calculators in this case, but if you can do it in your head, that's even better. Y equals 2x when x equals negative 3. So I need to calculate 2 times negative 3. I know that a positive times a negative gives a negative answer, so 2 times negative 3 would be negative 6. That skill is used when working with the equations of graphs. Now, the equation of a graph just describes that relationship between the x and the y coordinates like we've just been looking at. They're usually written in the form y equals something x plus something. Here's 2 examples then. What about the line y equals 3x? Well, that just means the y coordinate is 3 times the x coordinate. So let's find out these missing values. If I know that my x value is 6, and I know that because it's the first value there within my coordinate, then my y value is 3 times that x coordinate. 3 times 6 gives me 18. What about if they were to give me the y coordinate then? So this time I know that my y coordinate equals 9, and I need to work out my x. Well, remember, I know that the y coordinate is 3 times the x coordinate, so let's work backwards. 9 divided by 3 would give me 3. Let's see another example. What about the line y equals 2x take away 1? Well, that just means the y coordinate is 2 times the x coordinate and then subtract 1. So if I had an x value of 6, the y coordinate would be 2 times that 6 and take away 1. That gives me 11. Similarly, what if I had the y coordinate this time? I know the y coordinate is 9, so I have to work backwards. So add 1 to it and divide it by 2. That would give me 5. Have a go at filling in these tables for the coordinates. You're given the equations of the lines here, and you're given the values of x that you should be substituting in. So firstly, substitute x equals 0, then x equals 1, then x equals 2, and finally x equals 3. Pause the video, and when you're ready, we'll go through the answers. Okay, let's fill in these tables together then. If x was 0, 5 times 0 plus 2 is 2. 5 times 1 plus 2 is 7. 5 times 2 plus 2 is 12. And 5 times 3 plus 2 is 17. What about when the equation is 2x minus 7? 2 times 0 take away 7 is negative 7. 2 times 1 take away 7 is negative 5. 2 times 2 take away 7 is negative 3. And 2 times 3 take away 7 is negative 1. And finally, what about when the equation is 7 take away 2 lots of the x? Well, 7 take away 2 lots of 0 is 7. 7 take away 2 lots of 1 is 5. 7 take away 2 lots of 2 is 3. And 7 take away 2 lots of 3 is 1. Have a go at these quick questions about working with tables of values to do with equations of graphs. Find the value that should replace the star. You've got 5 seconds, but if you need longer, just press play when you're ready for the answers. My equation here was 3x take away the 1. I know that my x equals 2. So 3 times by the 2 take away 1 would give me 5. B is the correct answer. Pick the 3 values that complete the table of values for y equals 4x take away 2. I need to work out all of these. So my equation is 4 times by the x take away 2. Well, 4 times negative 1 take away 2 is negative 6. 4 times 1 take away 2 is 2. And 4 times 2 take away 2 is 6. So I'm looking for negative 6, 2 and 6. C is my correct answer. Which of the following points does not lie on the line y equals 2x minus 5? Have a go at substituting in the x value that they've given and see if you get the y value that they're showing. If you do, then it does lie on the line. If you don't, then it doesn't. Okay, in this first one then, I've got an x value of 1. 2 times by the 1 is 2. Take away 5 is negative 3. So that one does lie on the line. What about an x value of 0? 2 times 0 is 0. Take away 5 gives me negative 5. That one does match. It does lie on the line. What about x equals negative 3? 2 times negative 3 is negative 6. And if I take away 5 from that, I get negative 11, not negative 1. So this point does not lie on the line. Now we've worked with table of values, we're able to actually plot the graphs of these equations of lines. First of all, start by completing the table of values as I'm going to do on the example. So if I know my equation is x plus 5, so whatever the x coordinate, add 5 to it and I'll get the y. If I have x equals 0 and I add 5 to that, I get 5. 1 add 5 is 6. 2 add 5 is 7. 3 add 5 is 8. 4 add 5 is 9. Now I can read from my table of values the coordinates that need plotting. This is telling me that when x equals 0, y equals 5. So I can pair up my coordinates like that, reading from the table. I've got 2 more, 3, 8, and 4, 9. And now I can plot them. So I've got 0 and 5, 1 and 6, 2 and 7, 3 and 8, 4 and 9. You can see that they all fall in a straight line, and that's because we're looking at linear graphs today. There's a clue in that word. They're all straight line graphs. So to finish off, use a ruler and connect all of the points. Be sure that they go through the points exactly and extend beyond the points that you are given. Because that graph does not only exist between the points that you have plotted, you need to tell the examiner that you are aware it carries on further beyond those. What about one that involves multiplication then? Pause the video, have a go at filling in the table, and when you're ready, let's go through plotting the graph. Y equals 2x means just 2 times by the x value. Well, 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and 2 times 4 is 8. So let's plot these points. I've got 0, 0 to begin. 1, 2, 2, 4, 3, 6, and 4, 8. Again, you would obviously use a ruler to connect these points. I'm trying to do my best on this graphics pad. And again, make sure they go through all of the points exactly and extend beyond. What about one of those ones then when it's got a multiplication and then a manipulation of that? Here I've got an example of 3x take away 2. Substitute the values of x in that we have and find the values of y to get the coordinates that you must plot. 3 times by the 1, take away 2 is 1. 3 times 2 take away 2 is 4. 3 times 3 take away 2 is 7. 3 times 4 take away 2 is 10. Now I've got the points 1, 1, 2, 4, 3, 7, and 4, 10. This is going to be a little bit tricky to draw on freehand. Obviously, you would have a ruler in real life, makes it a bit easier, but I'm still trying to extend beyond those to show the examiner I know it goes on further. Let's take a look at some horizontal and vertical functions. Here I've drawn one onto my graph. This is a horizontal function. It's running parallel to the x-axis. Let's take a look at 3 points that lie on that line. I've got 1, 3, 4, 3, and negative 4, 3. What do you notice in common about all of those? Well, yeah, they all have a 3 in them, particularly in the y position. So therefore, it means that every point on that line satisfies the conjecture that y equals 3. So therefore, the equation of that line is just y equals 3. Let's look at some more. What do you think the equations of these following lines would be then? Well done. It's the y equals 1 line. What about this one? Yes, y equals 5. And finally, that one would just be y equals negative 5. Let's have a look at this type of function then. Again, let's mark on 3 points that lie on that line. Negative 2, 0, negative 2, 4, negative 2, negative 4. This time, they all have in common that they've got a negative 2 in the x position. So every point on that line satisfies the conjecture that x equals negative 2 this time. Therefore, the equation of that line is x equals negative 2. What about these lines then? X equals 2. X equals negative 1. And x equals negative 5. I just remember them as what number is it going through and what axis is it cutting across. Now let's look at the more complicated equations of graphs then. Now the equation of a graph, as we said before, just describes the relationship between the x and the y coordinates. We said before that they're usually written in the form y equals something x plus something. We can talk about them having special meanings. So if I say it's the form y equals mx plus c, it's probably ringing a bell for you. You're probably remembering this type of work. You may have heard it as y equals ax plus b also. That's because the coefficient of the x, which is my m value in this case, denotes the gradient of the graph, whereas my c value denotes the y-intercept, essentially where the graph cuts across the y-axis. So let's have a look at some equations and see if we can identify the gradient. In this one then, I want the gradients for all the equations. That would be the number that is attached onto the x. In this case, that's a 3. So I know that the gradient for this line is 3. What about here? Yes, the gradient is 2. Perfect. The gradient is a half in this case. What about this one? Well done if you didn't fall into the trap. Remember, it's always the number that's attached onto the x, which you may think is just 5, but it's actually negative 5. So be sure to watch out for what sign is attached onto it as to whether it's a positive or negative gradient. What about the y-intercepts from those equations then? Where does it cross the y-axis? Well, this equation just cuts the y-axis at positive 1. I can see that as it's the additional bit of my equation, plus 1. What about here? What's the y-intercept? Yes, it's negative 1. On this one, the y-intercept is positive 2. What about on this one? The y-intercept is positive 4 in this case. Do watch out for where they don't appear with the x as the leading term. So what exactly is a gradient then? Well, the gradient is just a value that represents how steep the line is. A positive number indicates that a line slopes upwards, such as this one, whereas a negative number indicates that the line slopes downwards, such as this one. How do we calculate the gradient then? Well, the gradient is just said to be equal to the change in y between two coordinates divided by the change in x of those two coordinates. To calculate it, we just need any two coordinates that lie on the line. I've called them x1, y1 for my first point and x2, y2 for my second point. The gradient then would be the difference between the y coordinates, so y1 take away y2, divided by the difference between the x coordinates, x1 take away x2. Let's have a look at a couple of those then. Remember, I only need 2 points. So for this one, I'm going to choose the 2 end points. Firstly, let me write out my points then. So my first point, x1, y1, is going to be 2, 5. And my second point, x2, y2, is going to be the point -2, -3. I could have chose easier points, but I do want to cover this working with negatives as well. So remember, my gradient, which is my m value, is the change in y. So y1 take away y2 divided by x1 take away x2. So that would be this value take away that one, which is 5 take away -3. And all divided by x1 take away x2, which is 2 take away -2. Remember, if you try and take away a negative, you end up adding those numbers. So that becomes 5 plus 3, which is 8, and 2 plus 2, which is 4. Now 8 divided by 4 is just 2. So it means the gradient of that line is 2. What about a negative one then? Do you have to make any differences and allowances because it's a negative gradient? No, just choose those 2 points again. So this time, my first point, I'm going to be taking as 0, 5. And my second point, I'm going to be taking as that 6, 1. So my gradient m is y1 take away y2 divided by x1 take away x2. So that's 5 take away 1. 5 take away 1. And x1 take away x2 is 0 take away 6. So 5 take away 1 is 4 and 0 take away 6 is -6. So that's where my negative gradient is coming in. And 4 over 6, I can't work that out as being a decimal because it would give me a recurring decimal. So I'm going to keep it as a fraction but just simplify it down to 2/3. So my gradient here is -2/3. Have a go at calculating the gradient between these following points. Press pause, and when you're ready for the answers, press play. Here are the answers for those questions. Did you get them all correct? Well done if you did. If not, try watching the examples again and following it through using these numbers instead. Some quick questions now. You'll have 5 seconds, but pause the video if you do need longer. Let's find the gradient between these points then. So it's y1 take away y2, all divided by x1 take away x2. 2 take away 18 then is -16, and -2 take away 2 is -4. So that negative divided by a negative is going to give me a positive answer, and 16 divided by 4 is 4. So my gradient here is 4. The correct answer is C. What's the gradient of this line? Here, even though I didn't know my coordinates, they've handily given me the change in x and the change in y already. So remember, it's y1 take away y2, which would be my change in y, so that's 6, and the change in x is just 2. 6 divided by 2 is 3, so the gradient is 3 here. What's the gradient of this line? Again, they've given me the change in y and the change in x, so I just do 2, which is my change in y, divided by 1, which is my change in x. That's just 2. The correct answer is A. Let's now look at the equation of a line and how I can figure that out just by giving a picture of it. Firstly, I'd need to identify 2 coordinates that lie on it. I can read those from the graph, so I can see it goes through 1, 5, and it goes through 3, 11. So I have 2 points that lie on my line, 1, 5 and 3, 11. The gradient then would equal the change in y. This time I'm going to do 11 take away the 5. Because I've done it that way round, I have to do 3 take away the 1 on the bottom. 11 take away 5 is 6, 3 take away 1 is 2, and 6 divided by 2 is 3. So I know that my gradient is 3. My y-intercept, which is my c value, is where it cuts across the y-axis. I can see it goes through at 0, 2. So my c is plus 2. Therefore, the equation of my line is y equals 3x plus 2. Let's try one more. Pick up 2 coordinates that it goes through. So it goes through 0, 10 and 2, 5, I can see. Okay then, my gradient is the change in y. 10 take away 5. And the change in x, 0 take away 2. Again, I did it in the consistent way. So the first one take away the second one this time. 10 take away 5 is 5. And 0 take away 2 is negative 2. So it's going to have a negative gradient, which I can see from my graph here. And 5 divided by 2 is 2.5. Where does it cut across the y-axis? Here's my y-axis. It cuts across at 10, positive 10. So my equation of the line is y equals negative 2.5x plus 10. Have a go at these quick questions to find the equations of the lines. Okay, let's consider what's happening here. It has a gradient of 2 and it cuts across the y-axis at positive 1. So my equation of the line is y equals 2x plus 1. What about this one? Again, we don't even have the numbers on here, but we can assume that that's 1 and that's 2. So the change in y is 2, change in x is 1. That means the gradient's going to be 2, and it cuts across at 0. So it doesn't have an intercept. It's just got y equals 2x, because essentially it would be 2x plus 0, but we don't need to write that plus 0. There's also another thing that we might be expected to work with in our linear graphs work, and that is the point slope formula. This helps us to determine the equation when we're given just a gradient and one point that lies on the line. You can remember this formula, y take away y1 equals m bracket x take away x1, where y1 and x1 are the values of the coordinate that you do know, and then m is the gradient of the line that you know. These other y and x would stay as those abstract values to become the y and the x that are in your equation of the line. So let's have a see at applying this formula. I want to find the equation of the line with gradient 7, so that means my m equals 7, and it passes through 3, negative 8. So my x1 is 3 and my y1 is negative 8. Let's substitute it into here now. Y take away y1, which is negative 8, equals m, so I've got a 7 there, bracket, x take away, and x1 is 3. So let's expand this out and simplify this left-hand side. Y take away negative 8 becomes y plus 8 equals 7x take away 21. Thinking about our expanding bracket skills. Now I just want to get this plus 8 onto this side, and I do it by taking away 8 from both sides. So I get y equals 7x take away 29. This is the hardest skill that you'll be expected to master at a foundation grade for GCSE maths. Let's try one more. The gradient equals 3, so m equals 3, and it passes through the point 4, 0. So x1 equals 4 and y1 equals 0. Let's substitute it into here again. Y take away 0 equals 3 bracket x take away 4. Well, y take away 0, I don't need to write that 0 on, so it's just y on the left-hand side, equals 3x take away 12. That one was a nice one. Have a go at these quick questions then. Find the equation of the line that has a gradient of 4 and passes through the point 1, 7. So I can use the equation then. Y take away 7 equals 4x take away 1. So that would be y take away 7 equals 4x take away 4, and then just add 7 to both sides to get y equals 4x plus 3. The correct equation is D. What about this one? Let's start with y take away 9 equals 4 bracket x take away 1. So y take away 9, if I expand that bracket, I get 4x take away 4, and then add 9 to both sides to get y equals 4x plus 5. The correct equation is B. One final test question then. I've got y take away negative 5 equals 5 bracket x take away 2. Remember, take away a negative ends up adding that. So that's y plus 5 equals 5x take away 10, and then take away 5 from both sides this time. So that's 5x take away 15. C is the correct equation. Okay, we've looked at all of the skills we'd need to cover within linear graphs. I know there's quite a lot, so please take your time and try all of the supplementary resources either on the Moodle page or within the RISE programme. Thanks for watching.